I'm doing all of them. I don't care. I want to do them. I've been waiting all semester for them. I'm doing all of them. Okay, let's work with this one. You don't have to watch all these videos. If you want to tune out now, oh, that's okay. I'll forgive you. Left side, and you know what? Right side is just a sine x, so we can't really do anything there. We could change something here. We could change the tan. And then let's just leave the cos x as it is. So tan is sine x, I was going to say theta, over cos x, and it's multiplying cos x. And we would treat that as though it's over 1. No, can you see the answer? Boom, boom, there it is. Sine x. Therefore, left side equals right side. Quod erat demonstratum. Boom. That one was okay, a warm up. Ooh. Ooh. Look at this one. Cosecant business over here. Cosecant business over there. That's going to create a fraction on either side. And then there's a 1 on this side, so I could force a fraction. You know what? I think I'm going to start with the right-hand side for this one. I'm going to have to do some work on the left-hand side because this is just ugly and I don't... Oh. Oh. Yeah, that's interesting. Okay, never mind. I figured that side out. But let's work with the right-hand side because we can. 1 plus, change the cosecant into its reciprocal. Sine, of course we're using x again, theta. Force this to become any fraction that we want, so we could add that together. Okay. I'm going to force it to be a sine x over sine x. And I'm going to add 1 over sine x to that. And then when I'm adding fractions, or subtracting, we just add the top and then we leave the bottom as is. So it becomes that. Well, that doesn't look very nice. So let's let's deal with this side. Let's change that cosecant to 1 over sine x. Now it's multiplying 1 plus sine x, but we could force this to become a fraction if we put it over 1. And then when we're multiplying, we go straight across, and we get 1 plus sine x over sine x. And guess what? That is exactly the same as the right-hand side. This one says sine plus 1. This one says 1 plus sine. It doesn't matter the order because they're both positive. If this was a negative in here, then things would matter. But because they're both positives, like, we did it. And it did not look at all like where I thought we were going. Therefore, left side equals right side. One more. Oh, there's 2 of the secants over there. There's not just 1 of them. There's 2 of them. But that's still just 2 times cos over. Okay, okay. Ooh, ooh. What is this? This is a difference of squares. Oh, folks, this is about to get fun. This is about to get all sorts of fun. Watch this move. You are going to love it. I'm so excited. We're going with the left-hand side. Well, no. I'll show you right-hand side, and I'm going to move it over here because it's not as fat as the left-hand side. The left-hand side is going to take some space. This becomes 2 times 1 over secant is cos x, which if we simplified it would be 2 over cos x, because if we force this to be a fraction and then we go straight across. Okay. Let's look at the left-hand side. Can't do anything with the coses in the numerator. Nope. Can't do anything with a 1 plus sine x or a 1 minus sine x. They're not the same, so I can't just add them together. Does anyone recognize these? Are you watching this and thinking, how are we going to solve this, Myths? Oh, look at that. Oh, look at that interesting business there. What are those? Those are difference of squares values. Gives me some ideas, gives me some thinking. Bottom line, we've got two fractions, we have to make a common denominator. When we were doing questions that were your rationals, and you had a question where it was an x plus 1 and a question where it was an x minus 3, then it was a plus. You would multiply by the other denominator, like we've done this. So, let's delete that and solve it. So we need to create a common denominator here of 1 plus sine x, 1 minus sine x. 1 plus sine x, 1 minus sine x. And then 1 plus sine x, 1 minus sine x. So we've done this. Obviously not this question, but in the numerator, cos was already up here, and what was the part that is new to the denominator? This one. So we have to multiply that in the numerator as well. And up here, we've got cos. If we were really good mathletes, we would state all of our restrictions with these questions, but that's not what it's asking us to do, thank goodness. Okay. Now, don't get excited and cancel everything out, because then you'll end up right back to where we started, and that's a trademark of Trig, if you will. Students put work in and then they undo it because they can cancel it, but they forget that they just did all that work. So we want to keep this ugly. And all I think I'm going to do for this step, I don't know if this is going to help us. I'm a little bit worried about this move. But I think it is going to, yep. I think it is going to help us, yep. Okay. What does this give us? That gives us cos times 1 is cos x. Cos times negative sine is negative sine x cos x, because they can't multiply to give us an answer, so we just have to write them all out, plus cos x times 1 is cos x. Cos x times positive sine x is positive sine x cos x. Okay, and you know what? I'm going to FOIL the denominator just because I can. Let's FOIL. First, 1 times 1, 1. Outside, 1 times negative sine x. Inside, positive sine x. Last, negative sine squared x. And once you do it once, it's just the same over here because the denominators are the same. Minus sine squared x. There's a lot of fun happening all at once. Let's just deal with the denominators right now. I can't deal with the numerators. They're freaking me out. So I just FOILed, and now we got 4 pieces in the bottoms, and there's sines and coses everywhere. Let's deal with one thing at a time. Leave the numerator. I don't even want to look at the numerator. I'm just going to write it out. I'm not even going to deal with it. Cos x minus, and you might already see the move in the numerator, but I'm going to save that for another step. I'm going to deal with the denominator right now. So, 1, okay, negative sine plus sine. Hey, those cancel out. Minus sine squared x. That's got a ring to it. 1 minus sine squared x. That's got a ring to it. And I might have to consider my Pythagorean identities. 1 minus sine. Okay, okay, okay. Still gonna just work with the denominator just for one more. Just one. Cos x minus. And you can, at this point, if you start seeing the steps that you have to make, um, you can combine steps, but my warning is don't try to combine too many steps at once. It's better to write out 14 lines than to try to do too much and like overdo it, because then you don't know how to find your answer. So I'm just going to change the 1 minus the sine squared x into cos squared x. I like this move because if I look back up here, on the right-hand side, my denominator is cos x. I've got it down to cos squared x. Like, I'm getting there. Now let's work with the numerator. Cos plus cos. Well, that's two coses. And because I've got the denominator down to the same thing, all I do is add across the numerator. So cos plus cos is 2 cos x. And then negative sine x cos x plus sine x cos x. Guess what? These cancel out. They're not even going to add to each other because they give 0. So all of a sudden, we're just left with this. And what this means is that there's a 2 cos x, and then in the cos x, it means it's cos x multiplied by cos x. So we just say cos squared x. So one of these coses is going to completely cancel out. And we're left with 2 over cos x. That was awesome. Never thought I would be teaching this lesson. 2 Q E D, my living room. Too bad. I was so excited for it. Thanks for hanging out with me.